Hi guys, welcome back. Please make sure that you watch the part 1 because the concept that you learn from that tutorial, they are proceeding into this tutorial. So for us to calculate or for us to access a memory address or for us to access data in random access memory, we need to use, or the microprocessor itself, it needs to use these 4 registers, which are base, source, destination, and base pointer. By default, base SIDI registers, they work with data segment register. That is by default. And we have base pointer and SP, they work with stack segment. So whenever you want to calculate the physical address, you must know which segment to work with, which segment to use, right? And the other thing is we are having these four registers. They do not work like this. You cannot use base register with base point. You cannot use source index with destination index. You actually use this with either that or that, this with either this or that, right? That's why we say we have 2 registers which make up an offset or an effective address, like we said in the previous tutorial. So the combinations that we can come up with, they are shown at the bottom left corner here. This bx can work with si, bx can work with di, and these we can, with these 2 combinations, or with all these combinations, we can have an 8-bit displacement or a 16-bit displacement. That's it, as simple as that. And this displacement can be within the square brackets or outside the square brackets. Like I said before, whenever you see the square brackets, you must know that we are working with memory, and whatever which is inside the square brackets is what we call the offset or the memory address, where we want to put the data, or where we want to get the data from, which is from random access memory. You must also note that general purpose registers, they cannot form an effective address. If you try to use them, you create an error, or you just create a problem for yourself. bx can be used to access effective address, but it's 16-bit. You only use it when it's in 16-bit. If you have it as bh or bl, that's 8-bit, we cannot use 8-bit to access memory. Right, combining these square brackets, you access memory. Whatever inside the brackets, that's the effective address or the offset. So given that the physical address is 12345, you need to set data segment to that and source index to that. Right, here we are having a practical code example. We are moving 1 into bx. Now we are moving 1 2 3 4 into a memory address with offset bx plus 1. So bx is base register which exists in our list, and the value in bx is 1. So the offset is 1 plus 1. 1 plus 1. So we are offsetting ourselves from the starting address or the starting location of a segment, moving 2 times, because we're saying this one plus this other displacement, we get 2, and our offset is 2. We add it with the segment register by 10. So I'm saying we add it to starting location of the segment to get the physical address. The offset that we get from by calculating this using bx plus 1 is the same offset value that you get if you calculate using bx plus 1. and here we are getting 123, which is the contents of this offset. Right, here there's not much, but D8 is just standing for for 8-bit displacement, 16-bit displacement. And displacement can be a discrete or an immediate value. It can be an immediate value, and it's directional. By directional, I mean it's signed. It can be negative or positive, so that we know in which direction are we displacing ourselves to. It can our displacement can also be an offset of a variable. It can be a variable, or it can be anything that you want to use as an offset. Right, the displacement can be inside or outside the symbol, the square bracket symbols. Generally, the compiler takes care about the difference between 8-bit and 16-bit segments. And here is just an example of how to calculate physical address given these values. So here we are having 100 as our data segment value, 30 as that, 70 as that, and this is our addressing mode. We want to get the address, the memory address given this addressing mode, or given this code. We say for us to get the offset, we say 30, which is px, plus si, which is 70, plus 25. So this is 25, 70 plus 30, and this one is the starting address of the segment, and the segment that we are using is ds. I guess we are together, we are on the same page. So by default, the ds segment register is used for all modes except BP register. Right, this is a simple way of claiming of, or just knowing. If you find it difficult to know, just claim, but I don't encourage you to claim. But this is just a simple way for you to know all possible combinations. So you can use bx with si, bx with the di, and or displacement, bp with si and or displacement, bp with di or displacement. You must know that displacement is directional, or it's signed plus or minus, and it's either 8-bit or 16-bit. That is it. You can form all combinations, all valid combinations, using this kind of arrangement. Right, so as you see, bx and that never go together. They're just in that column, we don't say bx and pp, but we say this and that, this column and that column and that other column. Right, the value in segment register, we call it a segment, and the value in these registers which we use to access memory, we call them offsets. And this is a takeaway. You must know that if we are representing our offset like this, we mean to say this is our data segment value, or this is a segment value, and here we are having our offset. Fortunately, this takeaway is having an offset calculated already, and we are having our data segment given there. We just apply the formula that we have learned in this other tutorial. Right, let's look at practical examples. The first example is this one. What are we actually doing here? With this program, we are having an immediate value which is 1111. We are moving this value to a memory location which is 1234H. So our offset is 1234, and in memory we calculate the physical address where we are putting this immediate value. So quad 1 is being loaded to this memory address, and then quad 1, which is at this location, is being loaded to AX. Let's observe what I am telling you here. So this is what is happening. This quad 1 was sent to that